Good day po. So for this presentation, I'm going to report on the measures of disease frequency. So I'm Charmaine Prainding Lipol, a registered medical technologist and also an international medical laboratory scientist licensed by the ASCPS. So for the content of my presentation, so this is taken po dun sa module na sinend ni Doc sa atin sa Google Classroom. So the contents include the introduction, wherein there would be the definition of our population, factors influencing catchment populations, fixed and dynamic populations, as well as our subgroup analysis. Okay, so number 2, what is health and disease? So under here would be the definitions of health and the definitions of disease. Number 3, measuring disease occurrence. Number 4, types of calculations. So under here would be our ratios, proportions, rates, incidence, and prevalence. And number 5, the measures of disease frequency in public health. So for our introduction, we have here our epidemiology. So this is the study of disease occurrence and distribution in populations. So just as we have discussed last meeting, our epidemiology was derived from the Greek words epi, demi, and logi. So when we say epi, it is on or upon. Demi would mean the general population, and logi would mean the study of. So kung pagsasama-samahin natin yung mga yun, it is the study of our human population. So our epidemiology relies on understanding key concepts such as population, health, disease, and measures of disease occurrence. So in clinical medicine, doctors or physicians or our clinicians would diagnose individuals. But in the case of epidemiologists, okay, so epidemiologists would diagnose the population. That is why epidemiology is also referred to as population medicine. So in epidemiology, the study of disease occurrence extends beyond individuals to encompass groups of people or populations. Understanding populations and their characteristics then is essential for assessing health outcomes, at the same time for planning interventions, and also for informing public health policies to the public. So what is population? Populations are defined based on common characteristics such as residence, religion, gender, age, the use of healthcare services, or even life events. So our population is not merely the number of individuals, but also the number of individuals who share certain common characteristics, like their places of residence. Okay, so geopolitical entities like countries, states, cities, and neighborhoods are common ways to define populations. So aside from the geographical area that they live in, where individuals may share religion or a common religion, okay, gender, age, use of healthcare services, or they may be connected through a certain life event. So our populations can also be defined in relation to healthcare facilities or the use of these healthcare facilities like our clinics, hospitals, or medical offices. The catchment population of a healthcare facility refers to individuals who utilize its services. So this may vary, or these individuals who utilize such services may vary based on factors like distance, okay, medical condition, and insurance coverage. So people from rural areas or di kaya yung mga nasa malalayo, okay, may have a harder time to travel towards hospitals or di kaya sa mga tertiary hospitals just so they could be treated or diagnosed. Okay, so it is advantageous naman to those living near the hospitals kasi mas malapit sila geographically towards these facilities. Okay, so the use of healthcare facilities by individuals may also be influenced by the medical condition that they have, specifically if they have a certain medical condition which would require a specialist. Okay, so one example siguro would be people who are suffering from heart illnesses. Okay, they may need a cardiologist for that. So if the facility or the hospital that they have in their area does not offer cardiology services, or di kaya walang cardiologist sa hospital na yon, okay, they may opt into traveling to other hospitals na medyo mas malayo but would have cardiologists, okay, na doctors in there. O di kaya, let's say, psychologists or psychiatrists. So kung walang psychiatrist sa area where they are living in, or di kaya the province where they are living in, okay, they may opt to find, or they may opt to travel to cities, for example, in order to find, or di kaya to be treated by a psychiatrist, or to have the diagnosis of a psychiatrist. And also, our catchment population can also be based on factors like insurance coverage. So catchment populations of healthcare facilities, okay, tulad na nasabi natin kanina, can be influenced by those different factors. So for example, okay, let's say a certain department, or let's say a certain hospital, okay, has enhanced their capability or their services. Okay, so let's say nag-enhance sila by improvement or with the addition of a cardiologist. So it may attract patients from greater distances. So people who are in need of a cardiologist, even if they are from far areas, no, kung if their nearby hospitals do not offer cardiologists, they would indeed need to travel to these hospitals with enhanced services. So this would expand the facility's catchment area. So it's from the word itself, catchment. Okay, so mas dadami yung ma-attract na pasyente, mas madami yung makakatch na patients because of the certain enhancements, or because of the addition of certain services in a healthcare facility. Okay, so for example din po in laboratories, so let's say a secondary laboratory would opt to transition to a tertiary lab, or di kaya mas madadagdagan yung services na kaya nilang i-offer. So it could attract, no, additional patients or additional clients, no? Mas dadami yung catchment population. Mas madami silang makakatch or ma-attract na clients, no, based on the addition of these services nila. And not only that, but even other laboratories might also send some of their samples to these tertiary laboratories, especially kung wala silang ganong service lab nila. Okay, so other than that, socioeconomic status also plays a role, with public and private hospitals often serving distinct patient populations based on insurance coverage and based on income levels. So aside from our populations and catchment populations, we also have our fixed and dynamic populations. So life events such as medical procedures, childbirth, educational milestones, or military services can even define our populations. So first, we have our fixed populations. So membership here for your fixed populations are based on a permanent event like a historical occurrence. So, let's say for example po, yung mga residences in, I think that would be Hiroshima, Japan, wherein nagkaroon ng, kayo sila yung nabomba, I think yes, ng atomic bomb. So, they share in there a common experience, or a common historical or life event, no? They share that as a population, and there will be no additional members na mai-add sa kanila. They're already a fixed population. No additional members will be added to that population. Okay? Kasi hindi naman ulit Okay? Hindi naman ulit makaka-experience or hindi na naman ulit mauulit yung event na yon para madagdagan sila ng members towards their fixed population. So, they are united or they are defined in such a way that that certain life occurrence or that certain historical event has defined them as a fixed one or as a fixed population. Example rin po ang mga Jews who have experienced the Holocaust. So they are already a fixed population. There will be no new members that will be added into them. Okay, so that certain historical occurrence, hindi naman siya mauulit-ulit para mas madagdagan pa sila. Okay, so in simple terms, no, our fixed populations share this life occurrence or this life event, no, and there would be no further members that would be added into them, not unlike sa ating dynamic populations that could change, no, because there would be the turnover of individuals that could enter and leave that population based on any changing circumstances to them. So this changeable condition can range from residency or di kaya occupation. Okay, so for a dynamic population, okay, so in here, pwede pang madagdagan, especially if some individuals would migrate to this certain area and they would decide to live in there. So for example, if a person living in Isabela would like to transfer to Tuguegarao para doon siya tumira. Okay, so mas madadagdagan yung population ng Tuge with that migration. If a certain person naman would want to live Tuguegarao, to live in Isabela, or to permanently reside in Isabela, mababawasan yung population ni Tuguegarao, madadagdagan naman yung population ni Isabela. So, our dynamic population, okay, changes based on this condition. So depending on the reason of migration, okay, wherein people would enter and leave based on different circumstances that they have, okay, these populations can increase or decrease in time. Okay, next naman we have our subgroup analysis. So populations can also be further subdivided into smaller group based on a specific characteristics. So our subgroup analysis allows for a more detailed understanding of disease patterns and risk factors within populations. We have an example in there, gender or age subgroups within a population may exhibit different disease prevalence or outcome. So, kumbaga yung ating population, we may subdivide them or we may divide them into smaller group based on certain common characteristics. So, di ba sabi natin kanina, our populations can be defined based on certain common characteristics that the individuals in that place would share. So, if you can subdivide population into age subgroups, so iba ang population ng, let's say, 0 to 14 years old, iba naman ang population ng 15 to 25 years old, iba naman ang population ng 26 to 30 years old, and so on and so forth. If you're going to subdivide naman the population based on the sex, no? Iba ang population ng male, iba ang population ng female, or iba yung number nila, or okay, magkakaroon ng another group with also another data, but still they are part of that bigger population or the group where they are still included. So kumbaga subdivisions lang yung mga to. So based on the subdivisions, pwede tayong magkaroon ng more detailed understanding of disease patterns at the same time of risk factors within populations. So aside from that, what is health and disease? So the concepts of health and disease are fundamental in understanding the well-being of individuals and of our populations. However, the definitions of health and disease have evolved, and this has reflected changes in societal perspectives, kaya advancements in medical knowledge and improvements in healthcare practices. So, health muna tayo. Ano ba ang sabi ni World Health Organization? Health is defined by the World Health Organization as a state of complete physical, mental, and social well-being, and not merely the absence of disease and infirmity. So this definition emphasizes that health is more than just the absence of illness. So it encompasses a holistic well-being, okay, including physical, okay, so hindi lang siya limited to physical health, but also the mental health, the social health of a person, the behavioral health niya. No? So, okay, it is a holistic, no? It is for the holistic well-being of an individual. So health is seen as a key aspect of quality of life. This reflects an individual's personal sense of physical and mental well-being, and also their ability to adapt to environmental factors. So again, our health is not merely the absence of disease, it's not merely the absence of infirmity, but also a complete set of physical, mental, and social well-being that is important to the holistic well-being of a person. So how about disease? Disease naman po is defined as the presence of a specific pathological condition or deviations from normal physiological functioning. Okay, so epidemiologists primarily focus on the absence of health or the presence of specific diseases, injuries, disabilities, and mortality when measuring disease frequency. Okay, so defining a disease would involve the combination of physical examinations, of diagnostic tests, and even evaluation of signs and symptoms. But sabi natin kanina, no, the definition for health, okay, and also the definition for disease can evolve as knowledge about the disease improves. So expansion of case definitions typically leads to an increase in reported cases, while contractions may reduce case numbers. So changes in disease definitions must be interpreted in the context of broader public health interventions such as prevention and treatment programs, which can influence disease incidence rates independently of case definition alterations. So one example may be the definition of disease back then. So in historical times, disease may only be limited to contagious or communicable diseases or the physical ailments that is with signs and with symptoms, but hindi pa kasama back then yung mga mental health illnesses natin. Okay? Hindi siya considered as a disease, but now disease encompasses not only the physical ailments or communicable diseases or the contagious diseases that is caused by pathological organisms, but disease would also encompass even the illnesses that affects the brain or the mind, okay? The mind, the mental well-being, the social well-being, even the emotional well-being of a person. So it is a combination of behavioral, okay, physical, mental, okay, social. So just as health encompasses a lot of this holistic approach, okay, or this holistic well-being, disease would also encompass the absence of health or the anything that may disrupt the normal functioning in any of these aspects, whether that be physical, mental, social, or emotional. Okay, so next po is the measure of disease occurrence. So measuring disease occurrence is a fundamental aspect of epidemiology, enabling the assessment of the burden of diseases within populations. So epidemiologists consider three factors when quantifying, okay? Quantifying pa tayo, quantifying disease occurrences. So they would consider the number of cases. So again, we are quantifying disease occurrence in here or quantifying the number of cases in relation to the size of the population at risk and even the duration of observation. So failure to account for all three components can lead to misleading interpretations of your disease frequency. So our disease frequency is determined by the number of new cases occurring within a specified population over a defined period. So for accurate comparisons, it is crucial to standardize the data by considering population size and also observation time. So standardizing data allows for meaningful comparisons, and it ensures that conclusions drawn from these epidemiological studies are indeed valid and informative. So, for example, there's a hypothetical scenario comparing breast cancer or breast cancer frequency in two countries. So let's say Country A has a population of 50,000 and there are 100 new cases over 1 year. And country B has a population of 5,000 with 75 new cases over 3 years. So if we're just going to look at the new cases, okay, we may deduce na, uy, mas marami yung kay country A kasi 100 new cases sa kanila. Okay, but we have to look also at the population and also at the duration, okay? Or that duration of observation, no? So, di ba sabi natin kanina, there are three key factors in here. So, we do not only look at the number of cases, but we also look at the size of the population and also the duration of our observation. So, we have to standardize these both so that we may better compare them and analyze them and come up with a valid conclusion. Okay, so to make a meaningful comparison, we standardize the data by converting both countries to a population size of 100,000 over a 1 year period. Okay, so it's like looking at them in equal lenses. So we are going to standardize this one, ang ating country A and yung ating country B. Okay, so that would be 100 cases. Okay, for country A divided by, okay, the 50,000 na population. Sorry, mahirap magsulat sa mouse. 50,000 na population. Then multiply by 100. Okay, multiply by 100,000. Okay, so again, we would standardize the data, 100 cases divided by 50,000 population. So yun ang population ni country A. The answer to that, we're going to multiply with 100,000. Okay, so multiply by multiply by 100,000. We're going to get okay, divided by 1 year pa po. Divided by 1 year is equivalent to 200 cases per 100,000, sorry, 100,000 population in 1 year. So this would be for country A. Okay, so that is our first standardization. Next would be for country B. So for country B naman, okay, there are 75 new cases. Based on the problem, they have a population of 5,000. Again, we're going to standardize this data to a population size of 100,000 over a 1 year period. So we're going to get here 500 cases per 100,000 population in 1 year. So once the data are already standardized, we can finally compare, no? So we can finally look at them in equal lenses. So we can see here na mas mataas pala, okay? Mas mataas pala yung number ng new cases ni country B. Okay, so this is because we have already standardized our data. We find that country B has a much higher frequency of new breast cancer cases as compared to country A. Kasi 500 cases si country B per 100,000 population in 1 year as compared to the 200 cases ni country A. So that is the importance of standardizing our data. Kasi kung titignan lang natin yung number of new cases, no, that would be misleading. Okay, if we're just going to look at the new cases, we could say na mas madami yung kay country A kasi uy, may 100 new cases sila. But it's important to also, again, look at the key factors ng epidemiology. Okay, we look at the number of cases and also the size of the population at the same time, the year or di kaya yung duration of observation. All right, so for the next one, we have the types of calculations. So in epidemiology, various types of calculations are used to describe and compare measures of our disease occurrence. So we have to understand differences between ratio, proportions, and the rates. So this is essential for accurately interpreting epidemiologic data or epidemiological data. So first, let's go to our ratio. So for ratio, this is simply the comparison of two numbers. So two numbers wherein the entities or the values or the data represented by the numerator and the denominator may not be necessarily related. So our ratios can express relationships between different groups or quantities. So one example would be our sex ratio. Okay, so one example would be our sex ratio. So sex ratio would express the relationship between the number of males over the number of females. Okay, so we are simply defining in here ilan yung number ng mga lalaki to that of the number of your females. Okay? But other than that, no, ratio can also be used, okay, in different categories. So let's look at this problem. So between 1971 and 1975, as part of the National Health and Nutrition Examination Survey or the NANES, okay, they have enrolled 7,381 persons aged 40 to 77 years old in a certain study. So at the time of enrollment, at the first try, each study participant was classified as having or not having diabetes. So during 1982 to 1984, enrollees were documented either to have died or were still alive. Okay, so yung NANES daw, nung years 1971 to 1975, they conducted a study or a follow-up study wherein they have 7,381 study participants. So they first identified the 7,381 aged 40 to 77 years old as either diabetic or non-diabetic. Okay, so that was for years 1971 to 1975. And then hinayaan nila yung mga participants nila. They came back later on, 1982 to 1984, nag-follow up sila. Ilan sa mga classify nilang diabetic ang namatay, ilan sa mga classify nilang diabetic ang namatay, okay? Or ilan yung mga, okay, ilan yung mga na-document to have died or were still alive. So this is summarized, no? So we have here diabetic men. Nung una, in years 1971 to 1975, they are 189 in number. Pero nung 1982 to 1984, 100 of those 189 died. Next naman, you have this non-diabetic men. So at the start of the study, they have 3,151 na na-classify nilang non-diabetic na mga lalaki. When they came back in 1982, 811 died from those 3,151. Next naman, they also classified diabetic women. So in years 1971 to 1975, they have identified 218 diabetic women. When they came back in years 1982 to 1984, they followed up those 218. 72 out of those 218 died. Then they also classified non-diabetic women. So at first, at years 1971 to 1975, 3,823 yung mga na-identify nilang non-diabetic women. But when they came back in years 1982 to 1984, they followed up, no, 511 died. So we have here as problem of the men enrolled in the NANES follow-up study, 3,151 were non-diabetic and 189 were diabetic. So ito yon. 3,151 were non-diabetic men, 189 were diabetic men. Calculate the ratio of non-diabetic to diabetic men. Okay, so again, ratio is the comparison of two numbers. It can express relationships between two different groups. So we have non-diabetic men to diabetic men. So, sabi kanina, there are 3,151 non-diabetic men na na-classify and 189 diabetic men na na-classify. Now, 3,151 is to 189 ang ating ratio, but we can still further simplify this. So, okay, this is supposed to be in, ano po pala, dito, numerator and denominator. Okay, so just imagine there's a line in there. Okay. And then, okay, ayan po. So for this relationship, we can divide, no? Okay, we can simplify this ratio by simply dividing both by 189. So para lang tayong nagsisimplify back in elementary. So 3,151 divided by 189, 3,151 divided by 189. So you may use your calculators. Join me as we solve this. 3,151 divided by 189 would yield us 16.67. Or pag ira-round natin siya, 16 point, ay dito na lang. 16.7. So again, we have 3,001. Sorry, mahirap palang magsulat with mouse lang. 3,151 over 189 na diabetic. So 3,151 na non-diabetic and 189 na diabetic. So we may simplify this by dividing both values with the smaller value, with 189. Okay, so that it would yield us 16.7 is to 1. Okay, so initially in ratio, it should yield either numerator or the numerator equals to 1. So the better way to do it is to simplify this one. We would have 16.7 over 1, or 16.7 is to 1. So every one diabetic man, there are around 16.7 or 17 non-diabetic men. Okay, so for every one diabetic man, for every one diabetic man, there would be around 17 or 16.7 non-diabetic men. So that is our ratio. So, I hope that is clear. Next naman po, how about the calculation of ratio for different variables? So, example A city of 4 million persons has 500 clinics. Calculate the ratio of clinics per person. So, again, forgive me na medyo pangit yung sulat. I'm writing with the mouse, but we have here, okay, 500 over Yeah, 4 million. Okay, so again, we may simplify this one by dividing both by 500. So you would have 1 over 8,000. So 8K na lang pala ito. But that is supposed to be 8,000. So this is this one. There would be one clinic for every 8,000 persons in a city of 4 million individuals who has 500 clinics. So for our ratios, our numerators or denominators may not be necessarily related. So if we would simplify this 500 clinics over 4 million individuals living in a city, we simplify this by dividing both values by the lower value in order to yield 1 in the numerator. We would have 1 is to 8,000. So ito po yun. So there would be 1 clinic for every 8,000 persons. So next naman po tayo, we have the example B. So Delaware's infant mortality rate in 2001 was 10.7 per 1,000 live births. New Hampshire's infant mortality rate in 2001 was 3.8 per 1,000 live births. Okay, so we can see here na standardized na siya. Okay, so same na 1,000 live births and same then in the year 2001. So standardized na. So we calculate the ratio of the infant mortality rate in Delaware to that of New Hampshire. So nabanggit kanina that the infant mortality rate in Delaware is 10.7. So ito po siya. Okay, so again, we're comparing Delaware infant mortality rate to that of New Hampshire. New Hampshire infant mortality rate. So, shortcut ko na lang po yung infant mortality rate into IMR. Okay, so you would have there 10.7 for the Delaware's infant mortality rate and 3.8 for New Hampshire's mortality rate. Okay, so it will be 10.7, 3.8. So again, let us simplify this equation by dividing both values with the lower one. So you would have in there 10.7 divided by 3.8, we would get 2.81. Or kapag i-round off natin, okay, it's simply 2.8. Okay, 2.8 is to 1. So if it's 2.8 is to 1, how do we interpret that? Delaware's infant mortality rate, okay, Delaware's infant mortality rate is 2.8 times as high as New Hampshire's infant mortality rate. So if there is one infant death in New Hampshire, there would be 2.8 infant death in Delaware or 3 infant deaths in Delaware. We're going to round that as a whole number. Okay, okay, so ganun po sa ating ratio. We are comparing here the relationship of our values that would represent groups or quantities or population, and they may be of different variables or they may be of same variable. Okay, so I hope that is clear po. Next naman, we have our proportion. So for proportion, it also compares two numbers. However, for proportion, the entities or the data in here are represented by numbers that are related. Okay, so the numerator is a subset only of the denominator. And yung expression natin for your proportion is fractions or percentages, ranging from 0 to 1 or 0% to 100%. Again, it's the same with ratio. Okay, we are comparing two numbers as well. Okay, pero yung pag-report po kasi natin kay ratio, so we have there a column, no? For example, 2.8 is to 1 or 1 is to 8,000. So for proportion naman po, we express it as fractions or percentages. And the numerator is simply a subset of our denominator. The entities are related to each other. Okay, so they are of similar variables. And so we have here the calculation of our proportion. So this is also taken doon sa problem natin kanina with regards to the diabetic and non-diabetic men. So we're done with the ratio. So how about naman the calculation of the proportion of men in the NANES follow-up study who were diabetics? Again, sabi natin kanina that the numerator is simply a subset of the denominator. So if we're going to calculate the proportion of men, okay, ano kaya yung magiging denominator natin? Okay, so this would be the total number of men. Again, our numerator or this 189 diabetic men is simply a subset of the total number of men doon sa NANES follow-up study. Okay, so basically, the lower number would be in the numerator and the higher value would be in the denominator. So again, proportion of men in the NANES who were diabetics. So we have our 189 diabetic men. The total number of men, okay, we're just simply going to add these two. Okay, diabetic and non-diabetic men. Kasi yung sa numerator natin is the total number of men. So 189 plus 3,151 would yield us 3,340. Okay, so if you're going to divide that, 189 divided by 3,340, okay, you multiply the value by 100, okay, we're going to get 5.66%. So 5.66% are diabetic men. 5.66% of the total number of men are diabetic or classified as with diabetes. Okay, so 5.66%. So kung 5.66% ang diabetics, okay, 94.34% naman yung non-diabetic. Okay, so this is simply 100 minus 5.66, 94.34. We're going to validate that. Okay, if we're going to see the proportion naman of men who are non-diabetic, we're going to have 3,151 divided by 3,340, the value multiplied by 100. Okay, so multiply 3,000. So we're going to get 0.9434 multiplied by 100, 94.34% naman po yung mga non-diabetic. Okay, so it's like, okay, it's like in a pie. Hindi naman perfect. Sorry. Hindi na po pala magsulat with the mouse. So, ayun, let's say in a pie, this would be the 5.66% who are the proportion of the diabetic men and 94.34% naman ang non-diabetic men. So again, our proportion, as you can see, they are related, okay, to each other, or they are part of a whole. So our proportion, we relate them to the whole, okay, to a part of the whole. So they are, every proportion that we compute in here is a part of the whole. So for example, again, the numerator is simply a subset of our denominator. Okay, so for example B naman, it says there, calculate the proportion of deaths among men. So, alin dyan ang magiging numerator and denominator natin? Proportion of deaths among men, we calculate the deaths or the male deaths over the total number of deaths. Okay, so the numerator will be the deaths in men and the denominator will be the total number of deaths, whether that be men, women, diabetic, and non-diabetic. Again, the total number of deaths, okay, siya yung whole, okay, WHOLE, okay, that is the whole. And the numerator is simply a subset of our denominator, so that would only be the deaths among men. So, para po siyang ganito, deaths in men, okay, over the total number of deaths. So, we're going to compute that. We have here already 911, the deaths in men, divided by 1,494, multiplied by 100. We're going to yield 60.98%. or 61%. So that would mean that 61% of the deaths are male deaths, right? Or the deaths in men. 61% are deaths in men, okay? So we have here yung your turn na problem. Sabi niya dyan, what proportion of all study participants were men? So we are calculating in here study participants na mga lalaki. So, male study participants. So, what would be our denominator? Okay, all, okay, or the total number of study participants. Okay, so the male number or the male study participants, so we're going to add this one. 189 plus 3,151, right? Hindi pa mo siya masalat. Okay. Male would be 3,340. We divide that with the total number of study participants. So, ito po lahat yun. 189 plus 3,151 plus 218 plus 3,823. That would be 7,381. So 3,340 divided by 7,381, we're going to yield 0.4525. Pero hindi pa po doon nagtatapos. Again, we're going to multiply this by 100. Okay, so I almost forgot in here. Multiply by 100. Okay, so we're going to get 0.4525 times 100, 45.25%. So that is the proportion of the male study participants or the study participants who were men in this NANES follow-up study. So kung 45.25% yung mga male study participants, we minus that with 100, we can deduce na around 54.75% naman are female study participants. So again, we can come up with this kasi again, this is a part of the whole. Okay, so they are all a part of the whole. They are correlated as part of the whole. No? So that's it. So I hope that is clear. Next naman po, we have our rate. So for rate, it is a measure of one number divided by another, where time, okay, so we have here time involved. Time is an integral part of the denominator. Rates are commonly used in epidemiology to quantify the occurrence of diseases over a specific time period. In epidemiology, disease rates are often expressed as the number of cases per 100,000 population per year. So dito po papasok yung ating mga mortality rates, no? Yung mga rates of certain diseases, okay? Crude mortality rates, case fatality rates, mga infant mortality rates, crude birth rates, and so on and so forth. Okay, so we're going to look at some of our rates later on po, okay? But in the case of our rate, we're not simply comparing the relationship of two numbers, not unlike kay ratio. Okay, so they are also part of the whole, but time is an integral part dito sa ating denominator. Okay, so it quantifies the occurrence of diseases over a specific time period. Next. Okay, ito po yung mga examples na nasabi ko kanina. Crude mortality rate, case fatality rate, cause-specific mortality rate, age-specific mortality rate, maternal mortality rates. When we say mortality, okay, the deaths, infant mortality rate, the deaths of infants, the crude birth rate, and the crude fertility rate. So example is our maternal mortality rate. So the maternal mortality rate is really a ratio used to measure mortality associated with pregnancy. Okay, but this is part ng proportion po. So the formula would be the number of resident maternal deaths divided by the number of resident live births. Okay, within a specific time period, multiply by 100,000. So we have here a sample problem. So there are, if we have 84 maternal deaths in 2008 among state residents and 130,000 live births in 2008 to state residents, ay ano yung ating maternal mortality rate? So we follow the formula in here where we multiply by 100,000. So 84 divided by 130,000, multiply it by 100,000, you will have 64.6 maternal deaths per 100,000 live births in 2008 among state residents. Okay, so we have here the inclusion, or di kaya there is time in here, which is an integral part of the denominator. Okay? Ngayon, para later on po, makikita po natin yung ibang mga rates natin. So aside from that, we also have our incidence. So incidence naman is a fundamental concept in epidemiology that measures the occurrence of new cases of disease within a population in a specific time period. Okay, so there are certain key ideas in our incidence versus the measurement of new disease events. So incidence focuses on capturing the occurrence of new disease events, typically the first instance of the disease within a population. Number two key idea is the candidate population. Incidence considers a candidate population composed of individuals who are at risk of developing the disease. So factors determining candidacy include physiological susceptibility and absence of immunity. Next naman is the time component. So incidence accounts for the specific duration of observation, as the transition from health to disease requires time to manifest and to be observed. Okay, so basically, if it's incidence, we are referring to our new disease events or new cases of that particular disease. Okay, so this may be applicable in cases of an epidemic wherein in a certain population that has the occurrence of a particular disease in there or the constant presence of a disease in there, tas biglang tumaas, biglang nagkaroon ng panibagong new cases, okay, we would have our incidence. Okay? We may compute our incidence for this one. So the types of incidence measures cumulative incidence and also our incidence rate. So for cumulative incidence, it measures the proportion. Again, pag sinabi natin proportion, we are measuring ay not only the relationship between two numbers, but we remember that these two numbers are represented by, okay, they are represented by numbers that are actually related and are related to a whole. Okay? So proportion of the candidate population that develops a disease over a specified time period. Okay, so again, it measures the proportion of the candidate population or the individuals who are at risk of developing the disease, okay, that would eventually develop that disease over a specified time period. So the characteristic would range from 0 to 1 or 0% to 100%, and they represent the average risk of disease over the given time frame. Application, it is useful for assessing disease risk over a defined period, such as the lifetime risk of breast cancer. Kapag incidence rate naman po, it measures the occurrence of new cases of disease. Ito naman po ay per unit of person time observation. So characteristic is that it incorporates time into the denominator, and it is expressed as a true rate, 1 over time, and applicable po siya sa mga dynamic populations natin. So again, when we say dynamic populations, okay, meron pong turnover ng mga individuals in here. Application of our incidence rate is useful for studying diseases with varying durations and population dynamics. So we have here po yung mga formulas. So for cumulative incidence, we have here the number of new cases of disease over the number in candidate population. Again, di ba sabi po natin si cumulative incidence, it measures the proportion of the candidate population, the proportion ng mga at risk na actually have developed the disease or actually na nagkasakit. So, nung una at risk lang sila, ngayon nagkasakit na sila, they are part of the new cases of that certain disease over a specified period of time. So, kapag incidence rate naman po, these are the number of new cases of disease over person time of observation in the candidate population. Okay, so for incidence rate, this is the new cases per unit of person time of observation. So for incidence rate, it incorporates again time in the denominator. So these are the formula. Next naman po we have, okay, the use of our incidence. So incidence is primarily utilized for evaluating disease prevention programs and studying disease causation due to its focus on new cases. So since it is investigating the number of new cases or the new cases of disease, may mga panibagong kaso ng sakit, no? Pwede ring ma-evaluate yung mga disease prevention programs. So, di ba po we have different prevention programs. They could be primary, secondary, or tertiary. When we say primary intervention programs, these are intervention programs that we apply even before the onset of a disease or even before the exposure to the disease. In the case naman po of secondary intervention programs, these are programs or activities implemented, okay, when disease is already or there's already an exposure to the disease. So secondary intervention program is directed towards the halting of the progress of that disease. And for tertiary intervention programs or prevention programs naman po, the harm is already done or the disease has already not only has been established but already has done some kind of harm. So tertiary prevention is to prevent further harm from happening. Yan po kay secondary intervention, it is when the disease has already occurred, okay, or the disease has already established, is already established. So pag secondary, we prevent the halt or we try to halt the progress pala. We try to halt the progress of that disease. Okay, so your incidence can be used to evaluate, no, to evaluate whether these disease prevention programs ba are effective or not, or di kaya they may be used for disease causation. Okay, so incidence plays a crucial role in epidemiological research by quantifying the transition from health to disease within populations. So the natural cause or the natural history of disease in epidemiology focuses more on the changes or the subclinical changes or the occurrence of a disease from a general healthy person towards subclinical changes and then into disease. And then eventually that disease would either result to death or recovery. So understanding the nuances of cumulative incidence and incidence rate enables epidemiologists to accurately assess diverse or disease occurrence, identify risk factors, and develop targeted interventions for public health improvement. Okay, so aside from our incidence, we also have prevalence. So prevalence naman po is a vital epidemiological measure that assesses the frequency of existing disease within a population. So kung si incidence, it focuses on new cases. Si prevalence focuses naman on the frequency of this existing disease. So from the word itself, that disease has prevailed in that population. Okay, kaya po siya prevalence. Nag-prevail siya sa population na yan. It has been a constant presence in that certain population. That's why it is a burden in that community. So since it is a prevalence, that means na meron na siyang presence nito in the past. So there are past cases up until current cases. So may cases na nito noon, meron pa rin hanggang ngayon. Both current and past cases naman po. Yung kay prevalence. So there are two types. We have the point prevalence and the period prevalence. So for point prevalence, it reflects the proportion of the population that is diseased at a specific moment in time, akin to a snapshot. And for period prevalence, it denotes the proportion of the population that is diseased over a specified duration. So point is in a specific moment in time. Proportion of the diseased population in a specific moment in time. Kapag kay period prevalence from the word itself, there is a certain period or there is a certain duration. So this is the formula po. Point prevalence, existing cases over the total number of population at a point in time. Let's say July 2023, the number of existing cases in a population of 150,000 in July 2023. Pag period prevalence naman, number of existing cases over the number in total population during a period of time. So period of time, example, if the period of time may refer to the months of July to December. Okay, so there is a certain duration or there is a certain period in there. Now, our prevalence is influenced by both the incidence rate and the average duration of the disease within that certain population. So the relationship can be mathematically expressed as this. Prevalence is equal to incidence rate multiply the average duration over 1 minus prevalence. So the incidence rate or the rate at which your new cases would develop or the rate of new cases of disease in that population multiplied by the average duration of that disease within the population. Okay, gaano siya katagal na andon, average duration, divided by 1 minus prevalence. So that is the relationship, okay, the relationship of your prevalence and to that of our incidence. So prevalence is valuable for resource allocation in healthcare, also in estimating facility needs and studying chronic conditions where pinpointing disease onset is challenging. So prevalence serves as a critical epidemiological metric for understanding the burden of disease within populations. Okay? So whether assessing current disease status at a point in time or over a defined period, prevalence complements incidence in providing a comprehensive picture of disease dynamics and healthcare needs. So kung kay incidence, it focuses only the new cases now. Kay prevalence, it measures also the new cases now plus the cases before. Okay, yung mga cases in the past or the disease cases in the past. Okay, so since that disease has prevailed, that disease has been a constant presence in that certain community, right? It has created such a burden within that population. So being able to compute or di kaya po to identify the prevalence is valuable, okay, in resource allocation in healthcare. So if that particular disease has constantly been in there, okay, what may be allocated or ano yung pwedeng magawang program, kay ano yung mga needs na pwede nating ibigay or i-direct towards that population, right? So aside from that, prevalence is also helpful in studying chronic conditions. Okay? So ayan po. Now we have mentioned a while ago the relationship of your incidence and yung ating prevalence. So we have a problem in here. So figure 3.1 represents 10 new cases of illness over about 15 months in a population of 20 persons. So each horizontal line, ito po, each horizontal line represents one person. These are our 10 new cases of illnesses. This is a horizontal line. It represents one person. So the down arrow indicates the date of the onset of illness, and the solid line represents the duration of the illness. Okay. Duration of illness pala. And the up arrow and the cross represents the date of recovery and date of death respectively. So up arrow would represent the date of recovery, the cross would represent the number of or the date of death. So we have the dates in here sa baba. Okay, so iba-iba sila, no? There are down arrows in here. So dito, around this day, yung onset ng illness. And sa person number 2, we can see na okay, maaga siyang namatay. And again, meron naman yung mga late na nagkaroon ng onset of illness in here. We also see here person number 8 who died around April 1, 2005. Okay, so we also can observe 2 recoveries for person 7 and for person 9. So with person 9 being exposed earlier than that of person number 7. Okay, so let's proceed. Let's calculate the incidence rate from October 1, 2004 to September 30, 2005 using the midpoint population. Okay, the population alive on April 1, 2005 as the denominator and express the rate per 100 population. So, ang sabi, yung numerator daw ko natin is the number of new cases between October 1 and September 30. Okay, around October 1 to September 30. October 1, onset, the number of new cases between October 1 and September 30. So, dito, okay. So, 1, 2, 3, and 4. 1, 2, 3, 4. So, ito kasi is before October 1. This is October 1. And yung iba naman is after October 1. And sabi yung sa ating denominator, the population in April 1. Okay, so the population, April 1 population. So, 1. Population alive. Population alive. 1, 2, 3, 4, 5, 6, 7. I counted 7, but in the problem, the denominator is identified as 18. Okay, susunod na lang ho natin yun. So, ito po, the denominator expressed in there is 18. So, 4, the number of new cases between October 1 and September 30, divided by 18, the April 1 population, okay? Multiply by 100, we would have 22 new cases per 100 population. Okay, okay. Wait lang po. So, we have a population pala of 20. So, 1. Okay, so buhay pa pala ito dito. Buhay pa pala si person 3. So, dito pala kasi yung onset. Yeah, dito pala yung onset niya. So, ibig sabihin buhay pa siya at this time. So, 1, 2, 3, 4, 5, 6, 7, 8. Okay? Plus the remaining 10 doon sa population ng 20. Kasi out of this 20 population, you have 10 new cases. So itong 10 new cases is part of the 20 persons. So ibig sabihin there are other 10 na hindi new cases. So including that, plus yung mga bagong cases natin, we have a total of 18. Okay? So there would be 18 cases. Okay? That would be the total mid-year population. So, yung mid-year ho natin is yung April 1, 2005, yung nasa gitna. So, 4 divided by 18 times 100, we have 22 new cases per 100 population. Okay, example B, calculate the point prevalence on April 1, 2005. Point prevalence is the number of persons ill on the date divided by the population on that date. So, April 1, the number of persons who were ill on April 1. Okay, so April 1, sino yung mga may sakit? So, may sakit ito. May sakit to, may sakit to, may sakit siya, may sakit siya, may sakit siya, may sakit siya. So, 1, 2, 3, 4, 5, 6, 7. So, there are seven persons who are ill on April 1. Sorry. 7 persons were ill on April 1 divided by the population or the total number or the total number of the midpoint population natin. So, nabilang natin ito kanina, yun po si 18. So, 7 divided by 18 multiplied by 100, we would have 38.89%. So, that would be our point prevalence. Again, point prevalence is for a specific period of time. So, you can see na ang hiningi lang ni point prevalence is yung mga nagkasakit noong April 1, 2005. Okay, the number of the existing cases of disease, okay, noong April 1, 2005. And that total number of population noong April 1, 2005. So that is fairly different kay period prevalence, kasi as you can see, there is age duration. So sabi niya dito, calculate the period prevalence from October 1, 2004 to September 30, 2005. So the numerator of period prevalence includes anyone who was ill anytime during the period of October 1, 2004 to September 30, 2005. Okay, so for October 1, 2004 to September 30, sino-sino yung mga nagkasakit? So lahat sila. Lahat to sila, no? So all of them naman may sakit-sakit, may sakit, may sakit, may sakit. From October 1. Sorry po. From October 1. Yes. From October 1 to September 30, 2005. Yes. Lahat sila. Okay, so nagkasakit naman lahat. So, kahit dito yung onset niya, pasok pa rin siya sa period na October 1 to September 30. So, pati rin ito. Okay, pati rin yung mga yun. Pati rin to, pati rin po. Ayan. So, they're still in between the period, okay, ng ating given, no, from October 1 to September 30, 2005. So, that is 10 divided by the total population at 20. So, 10 divided by 20 multiplied by 100, we have 50%. So that is how we compute our incidence rate, point prevalence, and period prevalence. So next we go to the measures of frequency. So in public health, various measures of disease frequency are employed to understand the prevalence, the incidence, and the impact of diseases within population. So these measures provide critical insights into public health trends, by they inform policy decisions, and they guide resource allocation. So for example, we have there po our crude mortality rate. So for crude mortality rate, this is the total number of deaths from all causes per 100,000 population per year. So for example, in the United States daw in 2003, a total of 2,419,921 deaths occurred. The estimated population is 290,809,777. So, paano po natin siya makukompute? So, it's simple po, no? 2,419 is going to be the numerator divided by 290,809,777. So you will divide that one and we multiply that by 100,000. So we're going to get 832.1. So since this is a crude mortality rate, it means that in the United States in 2003, there were 832.1 deaths or 832 deaths per 100,000 population. Okay, so that goes the same po with the others, no? Okay, for cause-specific mortality rate naman, it refers to the mortality rate from specified cause for a population. So, this is the deaths that has occurred due to a very specific cause. So, the numerator will be the number of deaths attributed to specific cause, and the denominator remains the size of the population. So, this is expressed also per 100,000 population. So, again, you're going to divide in here. For example, ito po yung problem in the United States, a total of 108,256 deaths were attributed to accidents or unintentional injuries. So this is a cause-specific mortality rate, or the deaths that has occurred specifically caused by accidents or unintentional injuries. So 108,256 divided by yung ating total population na 298,09777, we're going multiply by 100,000, we're going to yield 37.2. Okay, so the cause-specific mortality rate is 37.2 or 37 per 100,000 population. Okay, next naman po, we have our age-specific mortality rate. So the deaths that has occurred or is only limited to a very specific age group. So for example, okay, now we have here a problem. The numerator is the number of deaths in that age group. The denominator naman is the number of persons in that age group in the population. So we have a specific age group na kabilang dito. Numerator, the number of deaths in that age group. Denominator, the total number of persons in that age group. So for example, we have this problem. In the United States in 2003, a total of 132,495 deaths occurred among persons aged 25 to 44 years old. So this will be our numerator, or an age-specific mortality rate of 156.2 per 100,000. So 132,495 divided by the total number of persons in that age group, which is 84,845,000. We divide that, multiply it by 100,000, we're going to get 156.2. So 156.2 ang age-specific mortality rate per 100,000 na 24 to 44 years old na katao. Kasi we are specifying in here the age group mismo. Okay, next naman po is the infant mortality rate. So this is the number of deaths of infants less than 1 year of age per 1,000 live births per year. So the formula is the following. Number of resident infant deaths divided by the number of resident live births multiplied by 1,000. So for example, this is the problem. 1,300 infant deaths in 2008 among state residents. over 150,000 live births in 2008 to state residents. So this will be the numerator. Kasi ito po yung number of deaths. Tapos ito naman po yung number of live births. So if you're going to divide that, multiply by 1,000, you're going to get an infant mortality rate of 8.7. 8.7 or 9 infant deaths per 1,000 live births in 2008 among state residents, or 8.7. Case fatality rates naman po is the number of deaths per number of cases of disease. So the case fatality rate is the proportion of persons with a particular condition who died from that condition. It is a measure actually of the severity of that condition. So for example, in an epidemic of hepatitis A traced to green onions from a restaurant, 555 cases were identified. 3 of the case patients died as a result of that infection. So if 3 of that cases died, no, we can deduce na 552, they have recovered. Okay, so the new cases or the cases that have died, or the cases or the number of individuals who have died because of that disease divided by the total number of those who were affected by that disease, multiply by 100. So that's 3 divided by 555 times 100 is equal to 0.5% ang case fatality rate. Okay, so other measures of frequency include the following: attack rate, the number of new cases of disease that develop per the number in a healthy population at risk at the start of the period. So, kumbaga yung numerator, okay, new cases of disease over the number of the healthy population or the healthy people who are still at risk. Okay. Population who are at risk at the start of the period. Okay, so new cases of disease develop per the number in